I Professor B.S. Deshmukh, lecturer of Mechanical Engineering Department of Maratha Vidya Prasarak Samajas, Rajarshi Shahu Maharaj Polytechnic, Nasik. Today, we discuss on the impulse principle under the chapter Steam Nozzles and Turbines of Thermal Engineering. Now, we discuss on the construction and working principle of a impulse principle. It primarily consists of a nozzle or a set of nozzles, a rotor mounted on a shaft, one set of moving blades attached to the rotor and a casing. In simple impulse turbine is also called the D-level turbine after the name of its inventor. This turbine is called simple impulse turbine since the expansion of the steam takes place in one set of a nozzle. Here is the diagrammatic sketch of a impulse principles which shows the number of components of a impulse turbine, which is how the steam is entering. There is shows the nozzle, casing of a turbine, then how the steam is will be exhaust. Also in diagram we show the where is the blade present, where is the rotor, then bearing, shaft. These are the various components of the impulse turbine. Also there is a show the velocity or the pressure diagram of a impulse turbine. How the pressure will be changes and how the velocity will be changes when the steam is entering in the turbine and the after exhaust of a steam. Now we discuss on the impulse turbine. The uppermost portion of the diagram shows a longitudinal section through the upper half of the turbine. The middle portion shows the actual shape of the nozzle and blading. The bottom portion shows the variation of absolute velocity and the absolute pressure during the flow of a steam through passage of a nozzle and blades. The expansion of a steam from its initial pressure, steam chest pressure, to the final pressure, condenser pressure, takes place in one set of a nozzle. Due to high drop in a pressure in the nozzle, the velocity of a steam in the nozzles increases. Now we discuss on the impulse turbine. The steam leaves the nozzle with a very high velocity and strikes the blades of the turbine mounted on a wheel with this high velocity. The loss of energy due to this higher exit velocity is commonly known as a carryover loss or leaving loss. The pressure of a steam when it moves over the blades remains constant but the velocity decreases. The exit or leaving or lost velocity may amount to 3.3% of the nozzle outlet velocity. Also, since all the kinetic energy is to be absorbed by one ring of the moving blades, only the velocity of a wheel is too high, which is generally varying from 25,000 to 30,000 rpm. However, this wheel or rotor speed can be reduced by adopting the method of compounding of a turbines. Compounding of a turbines is nothing but the which reduces the speed of a shaft. This the discussion in the wheel or rotor speed can be reduced by adopting the method of the compounding of a turbines. Thank you.